Hello guys, welcome to another episode of Relations and Functions. In this video, we're going to be discussing about relations. Now, in order to solve relations, you need to be knowing about Cartesian product of two sets. If you don't know that, I'll put the video link in the description. You can go and watch that first, and then come and attend this lecture. So, if you know how Cartesian product of two set works, let's get started. Behind me, I have two sets P and Q. P is set of P is equal to ABC. Q is equal to Ali, Bhanu, Binoy, Chandra, Divya. So we're gonna use this example to explain how relations works. So let us try to form P cross Q. P cross Q, which means it goes like this. So A into Ali, A into Banu, so A Banu, and so on. A Divya. Next B Ali, B Banu, so on. B Divya. And the last one is C Ali, C Banu, so on all the way up to C Divya. Now I'm going to define a statement. I'm going to define a set. So suppose the set name I'm going to call it as R, and I'm going to say that the first letter in the, so suppose I'll write set of all x comma y such that x is the first letter of y. First letter of y. So basically we're supposed to find the elements in which this whatever the x we have, it should be the first letter of y. For example, B Banu, so that like that, and A Ali. So we need to categorize those in one single set, and we're gonna call that as R. So what are all the elements which you can put in this set? So this you can put A Ali, because see, so the set says x is the first letter of y, is A is the first letter of this y, so this is x, this is y. So basically x should be the first letter of y. So A is the first letter of Ali. So we're supposed to find these kind of elements. So next thing which we can choose here is B Banu. We can choose B Banu, and then B Binoy. B Binoy. Try to solve this on your own. And then what else we can choose? You can choose C Chandra. C Chandra. I think these are all the elements possible here. Now basically what we done here is relation. What we found here was basically relation. So you're going to find the relationship between these two. You're going to frame as a relation and then list all those elements. So a relation is basically a subset of Cartesian product of two sets in which the elements are related to each other. So how these elements related to each other. So this is the first letter of this word. So basically a relation is a subset derived by describing relationship between first element and second element of the ordered pair P cross Q. That's what basically we did. So we described P cross Q, we got all the elements. We set up a relationship between first element and the second element like we did here. So X is the first letter of Y. See, we established a relationship, and then all the elements which we got from here was basically a subset from the set of P cross Q. So this was basically how a relation works. Now the next thing which you need to know is domain, range, and codomain. So please pay closer attention because people normally make mistakes in this. So domain is set of all elements in the ordered, so set of all first elements in the ordered pair of R. So you have this ordered pair of R. So you just have to basically list a set in which contain all the first elements of R in the ordered pair. So your domain in this case it's going to be A, B, C. So A, B, C. We have B two times. We're going to write only one time because number of time doesn't matter. Just have to write it once in sets. And the next thing is range. Set of all second element in the ordered pair of R. So you just have to list the second element in the ordered pair. That's your range. So that's all. So you have Ali, Banu, Binoy, and Chandra. And the codomain is going to be, so codomain is the whole set Q is codomain. So you do your P cross Q. So the next set Q, the whole set is basically codomain. So that was the basic definition of relations, domain, range, and codomain. The next thing which you need to know is arrow diagrams. So arrow diagrams is just like Venn diagrams. So Venn diagrams is used to visualize the sets. In the exact same way, arrow diagrams is used to visualize relations. So in this example, we have relation is framed as set of all x comma y such that x is the first letter of y. So we write the set which you're going to define the relation like this. So P we wrote like this in a circle and list all the elements inside the inside the circle, and we have Q and then write the same thing and then list all the elements inside the circle. And the next thing is, based on the criteria which they give, we're going to match those. So our criteria is X is the first letter of Y, which means just like what we got here, we're going to match like that. So this matches with this matches with these two, and this matches with this, and we just listed everything. But also you could have done this also, which is again correct. So either in this way or in this way, you can visualize relations. So this was arrow diagrams, which is a very good way of visualizing relations between two sets. Now we're going to solve some problems, and the textbook will be which I'll be using here is Ncert textbook of 11th standard. I'll put the textbook link in the description. You can go and download it for free. Now let's get started with the problems. So the problem is, let A equal to 1 2 3 4 5 6, define relation R from A to A by R equal to set of all x comma y such that y equal to x plus 1. In this we're supposed to solve, we're supposed to represent relation in the arrow diagram, and we're supposed to find domain, range and codomain of R. So let us try to solve the first one, which is finding the relation and then representing it in the form of arrow diagrams. So what I'm trying to explain, so the relation is framed like this: x comma y such that y equal to x plus 1. So basically your second number or the second order pair like this should be one more than this. For example, this is 1, which means this 2, so this should be one more than this. Or for example, if I say 2, this should be 3. If I say 3, this should be 4. So it's like that. So from your order pair, what you have, so your given set is A equal to 1 2 3 4 5 6. So it should not basically exceed what numbers it's there in with you. So A to A means you're going to basically pick up all the elements from A and A. So this is your one A and this is your another A, so which is 1 2 3 4 5 6. So let us try to write the relation in the form of Rooster form. So R equal to 1 comma 2 2 comma 3, and then what I can do, 4 comma 5, and then I can write 5 comma 6. Can I write 6 comma 7? 6 comma 7? No, I can't write 6 comma 7 because 7 is not there in this set. So this is not there, so this is cancelled out. So this was our relation. Now we're supposed to represent this in the arrow diagram. So this is our A equal to 1 2 3 4 5 6. Since we're trying to find the relation from A to A, so one more set is also going to be our A itself. So 1 2 3 4 5 6. Now we are supposed to match. So 1 is related to 2, so 1 is related to 2. Next 2 is related to 3, 2 is related to 3, 3 is related to 4, 4 is related to 5, 5 is related to 6. So this is the arrow diagram of this particular relation. The next what they're asking is domain, codomain and range. Let us first find domain and range. So domain, as I told you, is the first element of the ordered pair in the relation. So 1 2 3 4 5. So my domain is going to be 1 2 3 4 5. My codomain is going to, sorry, let us first find the range, domain and range. My range is going to be the second elements of the ordered pair in the relation. So 2 3 4 5 6. 2 3 4 5 6. My codomain is going to be my second set. Codomain. If you're having difficulty of how to find codomain, so just basically have to see. So we are taking A cross R, A cross A, right? So this second set is always going to be your codomain, always. So this is our codomain, which is basically A itself in this case. So our answer is A. So this is how you find the relation, and this is how we represent relation in arrow diagrams, and this is how we find domain, range and codomain. It's very easy. People don't normally get it, but it's very easy. So let us try to solve one more problem on this. So the next problem is, the figure shows relation between P and Q. Write the relation in Rooster form, set builder form, also find the domain and range. So it's given in the question like this. So PQ, so 9 is related to 3 and minus 3. 4 is related to 2 and minus 2. So you can see the thing. 4 is related to 2 and minus 2. 25 is related to 5 and minus 5. You might be seeing some relationship right now, but let us try to write the relation in Rooster form first. So R equal to 9 comma 3, 9 comma minus 3, 4 comma 2, 4 comma minus 2, and then 25 comma 5, 25 comma 5, 25 comma minus 5, 25 comma minus 5. So if you want to write this relation in terms of set builder form, it's going to appear something like this. So R relation equal to set of all x comma y such that y is the square of x. Y is the square of x, isn't it? See, if you square, so if you square y, you're going to get x. So square y, 3 square is 9, minus 3 square is 9, 2 square is 4, minus 2 square is 4, 5 square is 25, minus 5 square is 25. So you can write the relation in like this. So just try to observe the pattern between the numbers and establish a relationship like that. So the next thing which I'm asking is find the domain and range. As I told you, domain is all the first element in the ordered pair of relation. So 9, 4, 25 is your domain. So domain equal to 9, 4, 25, and your range is going to be set of all second elements in the relation. So range equal to 3, minus 3, 2, minus 2, 5, minus 5. What if they ask codomain? This the elements, all the elements which are there in this set, it's basically a codomain. So this was all about the relation. In the next video, I'm going to upload about functions. So for that, make sure to hit that subscribe button and that notification bar, and I'll meet you in the next video. Thank you so much for watching.